All right, guys, so we've been talking about probability in class, and we've talked about different words, different degrees of probability. We talked about things that are impossible. That means they can't happen, there's no chance. We talked about things that are certain. If something is certain, then it's definitely going to happen. We talked about things that are unlikely, which means it could happen, but probably not. We talked about things that are likely. It means they're probably going to happen, but still there's a chance they might not. And then things that are equally likely. There's a 50% chance, half and half, that it'll either happen or won't happen. So today we're going to look at some die. Now, a normal die has 6 sides. So if I were to roll the die, then we would see it lands on one of those. So this would be a 6. If I roll it again, we see a 3. Roll it again, I see a 3 again, and so on. Now, in a normal die, there are 6 different things that can happen. We call these things 6 different outcomes, 6 different possibilities. Now, the chances of rolling any one of these things, because there's 1 5 and 1 4 and 1 1, would be 1 out of 6. So when we're rolling a die, we basically have 6 different things that could happen. We could roll a 1, a 2, a 3, a 4, a 5, and a 6. Now, because there are 6 things that can happen, we can say that the probability of rolling any of these would be a 1/6 probability. They all have the same chance because there's one of each of these numbers on a fair die. Now, if we were to roll a die over and over and over, this is kind of what it would look like. So I'm going to use this dice simulator, and I'm going to roll over and over and over to show you what that looks like. And we're going to see what happens on this graph down here. So I'm going to click roll automatically, and you're going to notice that this graph is, so right now we have more 5s. Over time, though, as we get more rolls, notice we're over 100 rolls, this graph is going to start to even out because the probability of all of these is the same. Even though some of them are rolling higher right now, we're getting more of them, you'll notice that these bars are starting to even out. That's because probability tells us that all of these have the exact same chance of happening, which is a 1/6 chance. So even though we see 2 falling below here, we are going to see that eventually catch up because it has the same probability as the other numbers, and we'll start to see this even out. Notice we're already at 500 rolls, and as we continue, we'll see it even out even more. Now, if I were to add a second die, notice now that there are 6 things that can happen here, and there are also 6 things that can happen here. Now, if I were to roll 2 die and add together the number on each, in this case we would have a 5 and a 1, which makes 6. Now, if you think about the lowest possible number that could happen here would be a 1 and 1 on each, that would be 2. And the highest possible number here would be a 6 and 6 on each die, which would be 12. Now, today we're going to talk a little bit about what is the exact probability when we're dealing with 2 die, and that's what's going to come next. So when we roll 2 die or 2 dice, there are 12 different. Obviously, well, we'll look at all the numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I caught myself there because there aren't really 12 different numbers that you can roll, because hopefully we can figure out right off the bat that if we're rolling 2, that a 1 is actually impossible, because the lowest number we can roll is a 2, which would be a 1 with a 1. Now, when we're thinking of all the different possibilities here, we got to think of all the possible things that can happen. So first we could have, let's say our first roll is a 1. If I rolled my first roll as a 1, then my second roll could be a 1, 2, 3, 4, 5, or 6. That's 6 different things that can happen. So a 1 on my first die and a 1 on my second die. A 1 on my first die and a 2 on my second die. Now let's imagine our first die had a 2. The second one could again be a 1, 2, 3, 4, 5, or 6. Same thing with a 3. If the first die is a 3, the second die could be a 1, 2, 3, 4, 5, and 6. Now, you're going to notice that pattern continues with a 4. We could have a 1, 2, 3, 4, 5, and 6. With a 5, we could have a 1, 2, 3, 4, 5, 6. And then finally, with a 6, we could have a 1, 2, 3, 4, 5, 6. Now this shows us a map of every possible thing that can happen. If I rolled a 1 on my first die, the second one could have a 1, 2, 3, 4, 5, 6. That tells me we have 6 options here, 6 options here, 6 here, 6 here, 6 here, and 6 here, which gives me a grand total of either 6 groups of 6, so 6 plus 6 plus 6 plus 6 plus 6 plus 6, or 6 times 6, which is 36 different combinations. That tells me that when I am looking at this, there are 36 things I could roll with a die, with 2 dice. So, for example, rolling a 1, if I were to roll a 1 with another 1, if we look at our chart, that only happens here one time, a 1 and a 1. That means that 1 and a 1 would have a 1 out of 36 chance of happening. So actually the only way to roll a 2 here would be a 1 out of 36 chance, because the only way I can get it is if I roll a 1 and a 1. Now, some of the numbers, like 1 in particular, would be 7, has a significantly higher chance. Because if we look at all the ways to make a 7, well, we could have a 1 and a 6, we could have a 2 and a 5, we could have a 3 and a 4, we could have a 4 and a 3, we could have a 5 and a 2, and we could have a 6 and a 1. That is 6 different possibilities, which would be a 6 out of 36, or a 1/6 chance. That means there's a 1/6 chance that you will roll a 7. So 6 out of 36, or 1 out of every 6 rolls. So it's significantly easier to roll a 7. Now, one thing you're going to notice is as you get closer to a 7, toward the middle of these numbers, it's going to get easier to roll. Because just like a 2 up here was 1 out of 36, a 12 is also going to be 1 out of 36, because the only way to roll a 12 is a 6 and a 6. So we can really guess how many of something we're going to get by looking at the probabilities. Now, we can also, just like we did on the other one, we can take a look at a dice simulator, and we can make this go to 2 dice. And if we roll automatically, we're going to see a different type of chart here, because we're not going to see lines going straight across, because the probability of all these things isn't the same. So watch what happens. Well, let's roll automatically. And you're going to notice that as you get to the outside, well, first off, you'll notice a 1 has nothing because we said it was impossible. But you're going to notice that as you get to the outside numbers, a 2 and a 12, we see less of those, and we see significantly more of the numbers in the center. That's because those numbers in the center, a 6 and a 7, are much, much, much easier to make. Because the probability is higher because there's more combinations that can make a 7. So we start to see a graph that is higher in the center and lower on the outsides. As the probability goes down, the number of times that occurs goes significantly down.